This video is on trigonometric calculus, so we're just going to be looking at the derivatives of sine and cos, and then in the next video we will do integration of sine and cos. If we have a function sine of x, then the derivative of that function is cos x, and if our original function is cos x, the derivative of that is negative sine x. Just a reminder here of the chain rule, product rule and quotient rule, just in case you forget any of those, because they will be used throughout the video. First example, differentiate x sine x. So if we have a look here, we should be able to see we need to use the product rule because we have one thing with x multiplied by something else with an x in it. Therefore, it's a product rule. In our product rule, the way I like to do it is make a u and a v. So u would equal x and v will equal sine of x. Do the derivative of each of those. Derivative of x is just 1. Derivative of sine x is cos x. And then we just use our product rule. Up here, I'm going to use the one with the u's and v's. So our derivative will equal u, which is x times v dash, which is cos x, plus v times u dash, so it'll be sine x times 1. So our derivative is just x cos x plus sine x. B, we've got 4 cos squared 3x. Here we have cos x, and then we have something inside cos x because we have a 3x, which means we need to use the chain rule. So now we need to work out what our two functions will be to use the chain rule. So our u is going to be the cos 3x, and our y will be the outside, which is 4u squared. Because remember, 4 cos squared 3x is the same as writing 4 cos 3x all squared. They're the same thing. So you can see when we've written it this way in the red, that cos 3x is our inside function, which is the u, and then what's on the outside is the 4, and then u squared. And then from here we can apply the chain rule. So we need our derivative of each, so derivative of cos 3x. This is another chain rule in itself, really, but we will get derivative of cos is negative sine, and this will have negative 3 sine 3x, and derivative of y will be 8u. Now remember, for the chain rule we need to multiply our two derivatives together. So we'll have negative 3 sine 3x multiplied by 8u, and then we can put u back in, so it'll be 8 multiplied by cos 3x. And then we can just combine that together. So we can do the negative 3 times 8 sine 3x cos 3x. Then this actually simplifies down to negative 12 sine 6x. I'm just going to go to another page to show you how that works. So we know there's an identity where the sine 2x equals 2 sine x cos x. Now from here we could then say that sine 2x divided by 2 equals sine x cos x, and then it doesn't matter if there is a number in front of the x. We can then create a general form, which would be that the sine of 2 nx on 2 would also be equal to the sine of nx cos of nx. So in this case, we can see here that our n would be 3 in this situation. So we can use this rule here, and we can say that this will be negative 24. Well, that will stay the same. The sine of 2 times 3x all on 2. Negative 24 divided by 2 is negative 12, and that will be sine of 6x. And that's how that question from before simplifies. C, we want the derivative of tan x. Now the derivative of tan x, you can just learn what it is, but I'll show you how it gets to there. We know that tan x equals sine x on cos x. They're the same thing. I'm going to use a quotient rule. So u is our numerator, v is our denominator. We know that u dash Derivative of sine x is cos x, derivative of cos x is negative sine x, and then we can just use our quotient rule. So we'll have v times u dash, which would be cos squared x, cos x times cos x, minus u times v dash, which means this will become a positive because we're going to have negative sine x squared, so it will be plus sine squared x all over our v squared, so it will be cos squared x. Then from here, cos squared x plus sine squared x is one of our identities. We know that equals 1. It will be 1 over cos squared x, and that's our derivative. Part D, 2 sine x cos x. Once again, it's an identity, and we know that that equals sine of 2x, and then we can just do the derivative of that. So sine of 2x, as I said before, this is a chain rule. Just if you want to see how that works, our u would be 2x, and our y would be the sine of u. U dash would be 2, y dash would be cos of u, and then chain rule, we multiply our derivatives together. So we'll have 2 times cos of u, and then our u is 2x, so it'll be 2 cos 2x. Example 2, find the derivative of each of the functions. So first of all, we've got 3 e to the power of 5x plus sine 2x minus 7. Plus means we could just do each section separately, and these will both be chain rules, so we just need to try and start using our chain rule a bit more fluidly if we can. So our f dash x will be e to the 5x, we do the derivative of the power, which will be 5, multiply that down, so it'll be 3 times 5, which was 15, and then e to the 5x stays the same. Now we know the derivative of sine is cos. The bracket stays the same, and then we multiply that by the derivative of the inside, so the derivative of 2x minus 7, which is just 2. So then this will simplify down to 15 e to the 5x plus 2 cos of 2x minus 7. B, y equals cos x multiplied by ln x. One thing multiplied by another, so product rule. Cos x will be u, ln x will be v. If we try and go straight to our product rule, u dash, so derivative of cos, which is negative sine x, multiplied by v, multiplied by ln x, plus derivative of v, which would be 1 on x, multiplied by u, which is cos x, and then we can just make that look a bit nicer. Cos x on x minus sine x ln x. And then C, y equals cos of ln x, so this will be a chain rule, something inside something else. Remember, u would be the inside, y is the outside, derivative of each, and then for chain rule, multiply those together. So 1 on x multiplied by negative sine of u, put u back in, which is ln x, and then we can just simplify that, so it'll be negative sine of ln x all on x. Last example, consider the function f of x equals cos x minus sine x between 0 and 2 pi. First of all, we're going to find the x and y intercepts. So for the x-intercept, it's when y equals 0. So we're wanting when cos x minus sine x equals 0, which means we're wanting when cos x is equal to sine x. Think back to your unit circle, that type of idea. They are the same when it is 45 degrees or pi on 4. So x will equal pi on 4. Now, our domain is between 0 and 2 pi, which means it's going to be more than one option where they're the same. So sine x equals cos x there, but also at 5 pi on 4, which is in the third quadrant. Because in that quadrant, sine and cos are both negative, which is the third quadrant, and the first quadrant, obviously sine and cos are both positive. So our x-intercepts are at pi on 4, 0, and 5 pi on 4, 0. Now for our y-intercept, we want when x is 0. We want cos of 0 minus sine of 0. Cos of 0 is 1. Sine of 0 is 0, so it'll be 1 minus 0, which just equals 1. So our y-intercept would be at 0, 1. Part B, find the intervals on which the function is increasing and decreasing and find the local maximum and minimum points. So to find where things are increasing and decreasing and our maximum minimums, we need to find the derivative, which would be negative sine x minus cos x. To find out where increasing and decreasing, we need to find the turning point, so we make this equal 0. Do some rearranging from there, and we're then wanting when does sine x equal negative cos x. If we think back to the same idea as before, when sine and cos are the same, is at 45 degrees or pi on 4. Now we want when one is positive and one is negative, which would be in the second and the fourth quadrants. So when x equals 3 pi on 4 and 7 pi on 4. Now from here, we need to work out when things are increasing and decreasing. So we need to do our sine diagram. So we want to know before, in between and after these points, is the gradient positive or negative? So we pick a value less than 3 pi on 4, so you can just put 0 into the gradient equation and we'll find that that is negative. Pick a value between 3 pi on 4 and 7 pi on 4, you'll find your gradient is positive. And pick a number between 7 pi on 4 and 2 pi, and you would find the gradient is negative. It is decreasing between 0 and 3 pi on 4, and also between 7 pi on 4 and 2 pi. So we have to write it that way because the question tells us our domain is between 0 and 2 pi. And then it is increasing between 3 pi on 4 and 7 pi on 4. And if we think about it, where our maximum minimums are, if it's decreasing and then increasing, it means it's decreasing and then increasing. So 3 pi on 4 will be a minimum, and then 7 pi on 4 is increasing before that and then decreasing, so that will be the maximum. So minimum at 3 pi on 4, and then just put 3 pi on 4 back into the original equation, and that will tell you the y value, which is negative root 2. And our maximum is at 7 pi on 4. Put that back into the original equation to work out the maximum point, and that is at root 2. Part C asks us to find the intervals on which f is concave up and concave down, find the inflection points, and indeed we're going to sketch the graph. So to find concave up and concave down, we need the second derivative. So if our first derivative was a negative sine x minus cos x, that means our second derivative will be negative cos x plus sine x. Concave up and concave down, once again we make this equal 0. 0 equals negative cos x plus sine x. It means we're wanting when cos x equals sine x, which will be, once again, as we found in part A, at pi on 4 and 5 pi on 4. We need to do another sine diagram for these now to work out where it's concave up and concave down. So pick a number between 0 and pi on 4. You'll find that's negative, then it's positive. Pick a number after 5 pi on 4 and 2 pi, and then you find that's negative. So this tells us it is concave down between 0 and pi on 4, and also between 5 pi on 4 and 2 pi. It is concave up, where it is positive, which is between pi on 4 and 5 pi on 4. And then when we've done this, these 2 points here, because it does change concavity, at pi on 4 and 5 pi on 4, these are also inflection points. Our inflection points are at pi on 4. Put that back into the original equation to find the y coordinate. You'll find it's 0, and then 5 pi on 4. Put that into the original equation, and once again the y is 0. Now from here, part D, we want to graph this function. We know our minimum was at 3 pi on 4 and root 2. Our maximum is at 7 pi on 4. We're only going between 0 and 2 pi, so we can't go past the x-axis. We know the inflection points are at pi on 4 and 0 and 5 pi on 4 and 0. And so we can use this information to then graph our function. There we go. So that is our derivatives of sine and cos.